whether he is joining in this video ninja or not.
I'm not sure.
And I don't know why, but your voice is, I can hear some muffled also.
From my side.
Yeah, yeah.
Is it better
Still having.
now?
If you can unplug and plug, I think you are using Bluetooth only.
I'll just disconnect it.
Yeah, maybe. Are we audible?
Can you hear me?
Yeah, I can hear. Just on live side.
Yep.
Audible?
I Yeah, we are audible.
Yeah.
Yeah, great. So I'm Gautam. I'll be your host today. I'll also be the interviewer, and I'll be taking an interview of Tushar. So as the title has it's sorry, so hard, but I'm not starting to because that would be too cruel to start an interview with. So, introducing myself, I am a software developer at last year, and I have collectively around 4 years of experience. I have been package, so I started doing all this back in college. So that is
The software. I have made about 4.5 years. I started programming and on there. Yeah, I think
yeah. So practicing essay actually to keep your mind sharp, right? So it's a really good platform to start doing all the life, right? Be confident if anyone wants to approach and see like Tushar a good interview for a company, he can just come and watch your video over there, right?
and actually the fun like, solving these started.
Yep. So that will be me and Tushar. Uh, I think we can start the DSA session. And before that, is there any questions that you would like to ask the viewers or the viewers want to ask something to us? So Gunjan is telling that voice is breaking continuously. So is it fixed right now?
Mine is speaking or yours?
I think mine. Well, hopefully it is better now. Okay. So how good do you think you are with linked list?
I don't know, like it's a very long time since I have used it, but hopefully.
Okay. So do you know how to reverse a link?
Yeah, I do.
So this is the question now. So I want you to create a linked list first,
Okay.
populate some data, and then reverse it. And I want you to run this code.
Uh, have you pasted anything?
No, this is the entire question.
Yeah. You're telling it verbally.
Yeah. Yeah.
Yeah. So first thing we need to do a create list.
Yeah.
Second is populate data. Uh,
Yep.
you mean to say like add data into the linked list? What technique?
Populate data as in add data to linked list, as in like the linked list will be mainly be integers.
Okay.
So you have to populate integers. Whatever integers I'm
So
going to
I
give
need
you.
to print them.
Yeah, you also have to print by the end of that. Like whenever there is a linked list that is given to you, you also have to print.
And else.
Uh, this is the requirement for now. I want you to create the class, maybe make sure that the linked list is done properly, and then we have to print the linked list.
Yeah, sure. So initially starting with, you can say we will be having a class called linked list,
Yep.
and we also need to have class basic because we need to identify each and separately. So we can say we will be having class called node, and in node uh, we will be having a definition. So starting with this, like thing we might have to pass an value. So this value could be an integer, as you said, and this we can create an empty node also. So I think is by default put it as a none, as a by default. So you want me to create double linked list or single?
For now, it's going to be a single linked list.
Okay. So what happens like in single linked list? I think uh, basically go only the next pointer, can't go previous pointer. So I will be having a reference called next, self.next. Let's say it is this none value will be replaced by reference of next into safe dot value we can I equals to say the value. So this is structure of basically our node of linking.
Okay.
We have to use that particular node in the our linked list class. So in this class, I think we can say that there will be few functions adding to the. As you said, we need to populate data and okay. So we will be having few functionalities like add to link list, remove from that link list, right? Or do I just have to implement adding function?
For now, add and then print. That would be
Okay. So definition like first will have to initialize the link. So I will as a uh, over here. Actually, I'm going to create variable like which will show tell me like what link list. I think we can do it outside the linked list itself. We have to do, but yeah, we don't need to do that basically. But it's much way better in that case. Tracking that head will be much more easier in this. So I will say link head equals really node.
okay.
So in this case, this we are just creating a blank node like so it will be having no value in pointer. So each and every time we will be having a head pointer which is accessible all the time. Uh, uh, we can always access that value if so in case we want to let's say sales uh, single link list, there are few problems like we have to alter that particular link, find the last node. That case, we'll have to traverse all complete link. Don't want to do that. So I think we can tail pointer also. So self dot tail right now we can self dot head on. Yeah. So in this
Okay.
way, when addition operation, I am assuming that we will be adding at the back of the link or respective.
Uh, Either way, that on you. You want to push it from the head, or you want to put it on the tail. It's on you.
Yeah. So I think I'm assuming that we are putting at the tail. So tail pointer will be very useful in this case. So I'm creating a function add uh, add node. Really. So add node function we will be getting a value. Okay. So this value we need to create a node out of it. It and put it as a next of a tail. So basically sales dot tail dot next equals to uh, node. We will be passing that value and we want to change our tail pointer also. Save dot next
Okay.
save dot next save dot next save dot tail dot next. So in this way, we will be adding each and every new node at the back of the linked list, and also we'll be moving our pointer tail pointer to the next node. This way, we'll be able to do it in OAuth and operation, adding the. So let's come to traversing part, as you say, definition. You you want me to return an array or something like that, or just have want to print whole link
Uh,
array? Okay. So get array or get all nodes. Yeah? I think we can name it like this.
mhm.
Uh, so in this way, over here we want to traverse complete linked list and want to generate an array. So in order to do that, we will be needing a temporary pointer which will point to the current node itself. So our current node will be self dot self dot next, and we want to give an answer like answer array. So I'm right. So we want to do until while current is not equals to current uh, not none. So will be transit. For example, there is no element in the linked list. In this case, this while loop will not get executed. Will be returning a blank array. And if we found that value, first of all, we want to add it to the so answer dot append current dot val, and we want to move our current pointer to the next element. So current dot next. So in this way, we will be traversing whole current equals to current dot next. So eventually we will end up on the last node, and next of that last node is none. So we'll be exiting that while loop. will be generating that answer array. We just have to return this answer.
Okay.
So yeah.
Let me ask you one thing. We are assuming that this is the linked list will start with some kind of.
Right.
So I'm assuming that 913, when you're creating a node, it's going to be a dummy node, which is
Yes.
just there.
Yes. Yes.
So, uh, so you are doing standard. Can you remove that dummy node and like somehow get this to work?
Yeah, we can actually do that. So in that case, we will have to do like we will have to keep the head pointer at outside the linked list. We can also do it inside also, but will be an little bit tricky job. Let's do it.
No,
So
no, you don't have to do it. You don't have to do it. I'm just asking you, can you do it and what will be the strategy?
yeah, oh, okay, okay. So for that purpose, anyway, we will be having an head pointer outside the class, which will indicate the reference to a linked list class. Uh, if that class is there, then we can say that we do have a linked list. Then we can say we don't have a linked list. And eventually we will be creating that next pointers. So in this case, for example, we are starting from self.head.next, right? So instead of that, we will be starting at the self.head. We are defining head value inside the class. We'll be starting at the self.head. So that way, I added that dummy node just because in some operations it's easier to do few operations using the dummy node itself. Like for example, you want to add element at the front, yeah, like front of the linked list. So I can just say that we are already have a dummy node. Okay, we can temporarily take like we can create a new node, reference that node to the next of the dummy node, and change the reference of next of dummy node. We already added that element. Second thing, as you said, reversing a linked list. So reversing a linked list is a very tedious job. Like we have to do some delinking operations and reversing operation. I think in that case also we will be able to do it much easier using this. I think yeah. So it's up to the use cases also, like whether to add it or not.
So you mentioned reversing a link. So
Yes.
can you add a function? Yeah.
Yeah, sure. We can. So let's just say definition reverse and so we already have a head right now. So there are, I think, ways to do it. Uh, One is that can do it through recursion. Basically, we'll be using the stack memory in that case. Second way is to do using without using a stack, like using a while loop or something. Okay. Yeah.
So which one do you think is tougher?
Yeah, without using. Uh,
I want you to honor a
yeah, yeah, sure.
without return.
Let's just plan out what we are going to do. I want to take some example in for solving this. Let's say we are having. So let's say we are having particular link. Hope I can. So actually, it is not starting from there. Will be having an head node for you. This will
Yeah.
start like that. So in this case, what we want to do, first we want to delete this particular element. So um, basically, we want to delete this, then do reverse operation on this particular. We're not going to reverse it from here itself. So rather than doing it, we first delete this part and then reverse it. In order to reverse it, let's just, so our problem is now sit down to reverse it. First, we need to move this reference, and after that, we will be directing our to one dot next to the two, and of course, two dot next will be gone. So we want to keep a reference of it like this. Then we will be having a tail pointer at this point, some of a reference, some one reference at this point. So we can say that three dot will go. Sorry, uh, we will have to update that particular temporary variable, that reference for 4 we need to store, and then we can say that 1 comma 2 of 3 4. In next step we will be doing same operation, 2 3 4. So in this way, particularly operation will going to look like. In order to do that, we will be needing few temporary variables to, for example, we need to store the reference of 2. Also, we need to store the reference of 3, right? But in order to remove this link 3 to 4, we will be having another reference which will be storing 4 basically. So I will be calling, let's say, current head equals to 2 this case, and 3 will be our head. So uh, remaining remain equals to 3. That will be our basically next node to reverse. So in this way, we will be handling it. For 4, we can say that temporary variable is a 4. Whenever we delink this from 3 to 4, we store it as a 10. We connect 3 to 2 as a variable. Our current will then change to 4, and current head will go to 3. This case, time will be again up to us. Like we are not going to use temp in that case. Uh, uh, Process will follow. Okay. So, are you fine with this approach, or
Yeah, that works.
yeah,
Can you do a quick
yeah,
code
sure,
for this?
yeah, sure,
We also
sure,
want
sure,
to entire do in like 45
sure. So, I'm
no
putting
pressure.
a, yeah, dot, uh, just going to. So also in this, I forgot to mention that in the end we will have to connect this reference of 4 to the head. So yeah, um, save dot head dot next, and can say that save dot head dot next equals to none. So in this way, we did the first step of delinking this part head to 1, and now while also we'll be needing an current head. We'll be needing a previous counter. So at any point we reach the none pointer, we will refer the previous counter as a uh, uh, hit of it. So while current head, it means we did not receive any none pointer at for now. So also, like, if not current head, then we can simply return in this case, because already there is no element in. And if current head is there, we want to keep the remaining pointer. So uh, equals to basically we want to delink it, so it remain equals to current dot next. Uh, doing some
No, no, go on, go on.
okay.
Doing fine.
Yeah. So current head dot next. Okay, current head is should be none in this case, but quickly. Yeah. Remain equals to current head dot next, and current head dot next equals to uh, none. So we basically delete that particular pointer, and also uh, previous pointer uh, we want to take as a current head equals to previous dot next. Now I think uh, second to take a remain.
Yeah, there's a small minor bug here, but it's okay. I think we can solve this bug.
Yeah.
Uh,
Uh, yeah. Remain we put it as a current dot head dot next. So let's say we are at this point. Current head is 1. Remain is at 2. We delink that particular point. So current head dot next pointer is removed.
Mhm.
Then what we did, current head equals to previous dot next. So this is an wrong statement. Basically, this is the day there. So current head will come over here. Actually, in description, like while explaining, I put it is current head as a this pointer, but we are using it anyway. Uh, Previous dot next, current head equals to previous dot next. Also, previous equals to, we also have to update our previous value also. So previous dot next equals to now the remain pointer we took as a current dot next. Current dot next also we need to do it. So previous will come over here. We can say previous equals to none. Uh, so previous equals to none. Current dot next. Yeah, now this looks correct. So we take current dot next. Current head dot next equals to previous. So we delink it and put it as a back element as a true. Now current head equals to previous dot net, not previous dot net. It will be an it will be an remain. So we had take the reference of remain, and now after we put a reference, we can say that previous equals to before that we will have to update our previous value as a previous equals to 100. So in this way, I think we solved it. Yeah, little bit tricky, but this should be done. After this pointer, we want to put self dot head dot next equals to pillars. So yes, this will completely reverse our.
Okay, can you do a dry run for this?
Yeah. So basically, we are having particular uh, we are having this linked list, let's say. So At this point, current head equals to save dot head dot next. That is, it will be pointing to an one pointer.
Yeah.
Save dot head dot next equals to none. So in this operation, we actually remove pointer from head to one. So this is the real condition. Previous is none, and let's just say if current head is none, that is there is no element in this, then we are just returning it because we don't have to do anything.
Yeah.
Already there are no any. So remain is also none. While current head, okay. So remain equals to current head dot next. So in this case, this will be pointing towards two, as current is one head. So
Yeah.
it will be pointing to two. Current head dot next was to previous. So this case, we are removing this pointer and putting it as a none. Then what we are doing, we are storing previous as a current head. So previous will be one pointer and current head equals to remain, that is two. So it will back to two. Now come back to the remain. We are putting current head dot next. Next element of two is three, right? So this will be now three. We are doing current head dot next equals to previous. So this will remove this link, add it as this way. Over here we are putting previous equals to current head. Current head value is basically uh, 2 right now. So 2 will be updated. Current head equals to remain, that is 3. Now again we came back here. Uh, so remain equals to current head dot next. That is 3 next is 4. So we will put it as a 4. Current head dot next equals to previous. So in this case, current head is current head dot next equals to previous. So we will be removing this link and putting as a previous. Previous was 2 in previously. So this is the value. And previous equals to current head. So current head will be 3. Current head equals to remain, that is 4. So again, we came back here. This will be none right now. Current head dot next is none. Yeah. Now current head dot next equals to previous. So
Okay, I have to interrupt you. Can you run this code? I want you to compilate and then I want you to show
yeah,
this.
let's say we are having a linked list equals to the linked list over here. Let's say L dot O. Now we want to first get all print. Then we want to reverse link ladder, and also we didn't want to print. So I don't know, is there an option over here?
I think I can run it.
Yeah.
Can you save the file?
Sorry. Do I have to save?
Yeah. Actually, wait.
Is it okay?
Let's see. I'm not sure why it's asking for Xcode, but
Uh,
I think there is some kind of confusion there. So uh, usually in an interview, sometimes they'll ask you to just run the code. Not really.
yes, yes.
I met some of them.
Is there any error in code or something like that?
Then I was like a little confused with the code, but it's okay. It's okay. Now, the lead code hard question that everyone is waiting for. Now we have like 15 minutes of time. I will discuss about this. Now, you know how to reverse a necklace now. But what if I tell you to reverse k sections of necklace? So if there is like 1 to 10 in the necklace, I want first 5 to be turned reverse and then the next 5 to be turned in reverse. And it's like that. So it should be like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It would be converted to 5, 4, 3, 2, 1. Then 10, 9, 8, 7, 6, 5. That's it. There won't be 5. You understand assignment, right?
Yes, got it, got it. So just a question, like this thing, do I have to do it code panel or like
No, no, same code pattern.
okay? I think good question. For example, like we are having a code, want to break it in parts, then have to reverse two, then 4 to 3. 4 will become one. I think.
So
So
I'll tell you how much we should be breaking. So it will be a k number of breaks that you want to keep, and you have to reverse a k number of.
yeah, so basically, if you are having so if you are having say k equals to 2, then we can say that one are basically will become one.
Yeah. I think I am not able. Oh, no, no, no. I think there was a. So I 3, 2, 1, 4. It's
Ah,
like
okay.
this.
Okay, okay, okay. So, fine, fine, fine. Yeah. Now, so, of course, we will be needing an counter in this case. Uh, and in that counter, basically, for example, while reversing, if that counter reaches the k value, we'll have to reset that counter. For example, let's just say k equals to 2. So came over here, 1 equals to 1. Let's say we reverse it. Uh, our counter is at point 2. Initially, it will be 1. Every single reverse will increase that value. Actually, the value will be 1. If value is 1, then we don't have to do the reverse operations, right? Because we are reversing k elements. One is reverse is 1 only. versus 2 only, versus 3. So it do not make sense. The value will be 1. So as soon as the counter hits the 4 value, the next 4. Yeah, as soon as our counter hits the k value, we know that now something we need to do, and that something is that uh, uh, yeah, I two next one. Yeah. So that something is uh, we want to reverse next part of it and put it as a next of one. Right?
Yeah.
Yeah. So for that purpose, we will be needing an head counter also, and we will be needing an tail pointer. I don't think we will be needing tail pointer. This will become an save dot head. Yeah. Mm, okay. Yeah. Interesting. Mm. So basically, what we want to do, we will be having a tail pointer at this one point and a head pointer at 2 points. So if there is no head, then only will be pointing towards the neck, and we will be putting next of tail was to reverse of this particular. So this will become 4 next 3, and will and let's say there are more elements like 5 and 6. Then also we will be having uh, as the head already is there as a value 2. We don't have to do anything. This we just have to do the next of reverse of 6 comma 5, that is 6. So it is very I think it is very important to identify where to relink that particular link. Okay, let's just I think start with particularly. Yeah. Can I
Yeah. Go on.
take a copy of this one modified?
Okay. Instead of doing that, can you use the same function
Okay.
then do that?
So
Yeah, you can actually copy the function. I think that would be much simpler.
so what I can see that this part while current part is going to be an recursive thing. Okay, like this is common thing we are going to.
Mhm.
So what we can do, we can put it to function and use it in our given function. So that way this will be here. Of course, there is a two-way thing. Like we can go k steps next and break that link, reverse that particular segment, add it back into the link. That is the thing. But it will take double iteration. So I want to do it in one iteration. That's why I wanted to uh, by copying it. Yeah.
Yeah, understood.
Uh, copy. So reverse ALL will be passing a value k. I'll just remove like this is really wanted.
Hmm.
Later on we might use it. Just removing comments so we do not get any confusion later. Yeah. So initially, as I said, our counter like counter equals 1. So whenever the counter reaches the pointer, that is counter equals to k. In this case, we need to do some operation. Uh, what operation we need? Like we will be having an basically uh, we we also need an tail pointer in this. So tail equals no, one second. One is yep, tail equals to none, and this case whatever the element at the back is there, here tail value. That case, whenever we are changing our previous element, uh, now the question is
Uh, we still have like 5 minutes. Can you just modify and just
yeah,
do a pseudocode? That would be
yeah.
good.
So we are doing tail equals to current head. So current head will be a tail in this. Uh, as soon as we reach this point, we will have to update our tail dot next to reverse of basically river current head. We will have to reset our counterpoint. Counter equals to 1. I think I'm missing something. Current head equals. This is not yet reversed yet. So if it was an recursive call, then it was much more easier. But tracking that point, already sorted that point. Previous will be the head. So basically, for example, we reverse this part. Let's just say we reach the 1 and 2. So 1 next 2 we reach and we are already reversing it. So 2 is the previous pointer and our current pointer will be at 3. Okay. So what we want to do, one dot next we need to change. So uh, one reference we are putting it in a tail and reverse of this particular thing we want to change. So reverse of this is not yet done. In order to do that, um, yeah, so we will be having two and let's say tail equals to none. Then. So let's say we reverse this particular linked list. We want to put as a none over here. So to next of one is we want to put as null pointer. Uh, tail over here that is none, and we can just update our tail pointer as a value 3. Anyways, this is going to be 3, right? We are going to point towards the we are going to point towards the 4. Something I'm missing right now. Take it. We're counting k. Dot next equals to current head. Count equals to 1. Um,
It's a little hard, right?
Yeah, I think I'm just missing that part. Like after the reverse operation, no. After the reverse operation is done, then only I want to do that. So uh, yeah, so that's where I'm saying if it was a recursible, it would have been yeah, 1, 2, 3. Dot,
It's okay, Tushar. Like,
yeah.
I think the question is a little too hard. Like, see, one thing I would suggest you is that
Mhm.
when there is a very hard question,
Yes.
uh, think about the entire flow.
Yeah. 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 I'm thinking of that only. Uh, some way like I think I had solved this question previously also, but now I'm missing. Um, I'm pretty sure that we need to change the count. We'll be needing this counter variable. Um,
Mhm.
so at any point of time, we reach the k value. We are going to reverse the remaining one and put the k value. So
It's okay. It's okay. See,
mhm,
uh, the thing is, it's
it, it,
like
it, it is going to be a previous equals to current previous equals to current dot next not tail dot next. So previous was no.
it's okay. It's okay. I think we can conclude this entire DSA. I think
Okay.
there might be a few questions that you might have.
uh yeah, so how do you face such problems like you know that you had solved this problem at some point, uh, you are not able to solve it, like you are not able to remember or get answer. How you face it?
So one of the things that I do is I just have a notebook beside me every time. Like it's one of the cheat code that I have. Like it's not a cheat code. I don't write the answers like this, but like I try to write it down. Uh, and then if I have the like I have the proper thing in my mind, most probably I can express it in a better sense.
Yes.
So the thing is, it's just it might take like 1 or 2 minutes to actually go through the entire exercise again. Because I'm pretty sure that this question is a lot of people have seen this question in LeetCode, and this is still considered to be a LeetCode hard. So
No, actually, I have solved it multiple times. It's just that it's been more than two. But yeah, I did solve. Uh, yeah.
this is okay. Uh, one review that I would like to give you is that sometimes the first question might be a warm-up question. So like try to solve it as quick as possible because most probably the next question is going to be more important and like more questions you solve in an interview, uh,
Yeah.
greater your chances are to go ahead.
Okay. I'm
And
actually slow in this thing, typing, and so it takes some time. And also, while typing, I always think of something that makes me more slower in this. How to improve?
yeah, I understood what the thing that you're facing. So while you're typing, you can't explain stuff, right? So what I do is usually there is code and there is comment. So whenever I write a code, I don't usually explain stuff. But before writing the code, I just write the comment and express the comment directly. So see, even if whatever I'm saying is different, the comment is more or less going to be the same. And then
Yes, yes,
I write the code.
yes,
So
yes.
that is one strategy that I always use. So yeah, even I face that problem. And a lot of people in this world face that problem. So it's not
Um,
a big deal.
yeah. So sometimes what happens, like, uh, I gave use asked to solve it. They do not even ask the approach or something. They just say that code it and how you face that uh, problem.
So yeah, I have actually met those kind of interviews. So uh, fun fact, Atlassian did an interview where I had to explain my code first, and then all of a sudden they told me to run the code. Just it has to execute properly. You're given time to build the entire thing, like, run the code so that you can test it out. So
Yeah. So like, do they does the approach?
so the first step is that they usually ask you how do you solve it. So you give some kind of answer, like some kind of solutions for it.
Yeah.
Then they would ask you to write the question answer,
Okay.
and then once that answer is like you do the code, they ask you to just run the code so then they can verify it. They will give you some test cases and all. So it's pretty like well known that Asin does it in this.
Yes.
There are other companies as well. GitHub also asks you to run the code. It's either GitHub or there was one company, not sure. But sometimes some companies do that, some interviews do that, interviewers do that. Sometimes you have to share your screen and then do it. So there can be multiple ways.
Yeah. Okay. So
So this time,
right, right. I just realized something. We are using a reverse case,
yeah,
and we have just say we counter point. We could have called this particular facing what we are going to of the tail.
yeah.
So that case, I could have just put d of this tail equals reverse tail linked list of remaining linked list.
Yeah.
Uh, first,
So basically, the entire exercise for this was I wanted you to start using the design of the code rather than solving the code by this thing. So,
yes. So
so yeah.
basically, yeah. Go ahead. Yeah.
So basically, I made you uh, make a class. Uh, I made you design a linked list, and then I started challenging you a lot. So what I was expecting was that you will use a linked list. There might be a bigger linked list. Maybe you might create smaller linked lists of size k each time, and then reverse each of them, and then just
Yes.
add all of them.
But in that case, like I will have to traverse both tail and head per next of.
Yeah. So
So
one thing you could have done was just add a counter as a what do you call it? A variable in your linked list, and each time that counter used to cross a number k, you can just call the reverse, and then you just after doing all that, so you do the k and then reverse it, and then for the tail you can just put the put that as a temporary variable and then point it like that.
so basically was imagining uh,
Mm.
so we put the next as a current head and just reverse that particular uh, this way, this is much faster and like much easier. Your approach, we have to traverse, I think, twice, I think, right? Linked list. We are
Yeah,
traversing twice. Yeah. So in this way, it was only once one loop.
yeah,
So that was I was trying to do. Uh, so maybe I was directly jumping on most optimal. So do you suggest this thing, or uh, one should go with less optimize and then
so the thing is, usually in an interview, uh, you can ask the interviewer. Like sometimes the interviewer, you can just say, "See, I'm thinking of this. Why don't I just make the solution for it like that?" So, for example, if I go like, see, I made a linked list class and I know how to populate the entire linked list. Now, what I will do is I'll make smaller linked lists. Like I'll take each value, make the smaller linked list, reverse it using the function that is already there, and then each time I do that, I'll just concatenate it. You can give solution like that. Okay, the thing is, in your approach, you are using two loops, but sorry, in your approach, you were using one loop. The thing is, it's okay to use two loop if the what do you call it? O of n, if it is O of n in both
hmm.
cases.
Okay.
So you are using two separate uh, loops. That is still okay. That is when you look at the space and time complexity, both if both are same
Both
and
are
one looks easier to read. Most probably you should go with that because uh,
okay.
maybe maybe it might take like it might be more optimal to do it, but at the end of the day, the interviewer might read your entire code maybe after 24 hours and then I didn't understand any of this. But
Okay.
the code quality makes a lot more of a difference because see, older we get, we try to write code which is understandable to humans,
Right. Right.
right? So we focus on design of the code. Performance comes with it, sort of. Uh,
Right.
you can always optimize it to a point where it's flawlessly quick, but the thing is, it might end up looking like a bunch of code that nobody wants to read. The code has to perform. Also, it has to be maintainable. So,
Right. Yeah. So,
yeah.
in this particular problem, I take it as a dummy node. Do you suggest this approach or suggest to not?
Uh, the dummy node approach actually it seems pretty reasonable to me because uh, at the end of the day, it's just one extra node. The thing is, there is a justified reason why this node was taken. So that makes like you can choose to take a dummy node or not take a dummy. It's your design.
So, my question was cannot expect other person to get node on basic, right? Like they are going all a linked list, all a object of a linked list, and it will not be having reference to a node, right? Initially.
Yeah.
So that's why I this way so that we'll be having a node first thing. Second thing, the other reasons I mentioned, some operations, the dummy node. So
Yeah.
yeah, that's why.
But more or less, the review for the interview is that uh, there are few things that you could be doing better. It's more or less just write the variables in descriptive fashion. Try to use the existing design and then start building on top of that. So, the good thing about uh, object-oriented programming is that you can actually make multiple functions. You're not constrained to using one function and put all the codes there. start leveraging all that. And uh, recently, a lot of companies started doing design plus DSA interviews. So for all the viewers ahead, just telling you, if you are using a proper design, there's a good chance that you might be given a like you might be given a good appraisal, or like you might be given a good chance to go ahead with the interview, and there is a good review that might be given to you.
So
So
how
yeah,
is this research? Like how many points? 5 or 6?
out of 10, around 7, I can
Ah,
give around 7. The
it's
thing is,
getting less actually.
no, like, see, if I give you a hard question, that means that
Mhm.
I'm at the end of the line and I want to make sure that I want to get all the data as possible.
Yes, yes.
The thing is, you did not actually go like, no, I'm going to write this code and then I'm not going to reuse the code. You make sure that the design is proper. Whenever you needed to add something, you did add it. When you saw that there is a reverse linked list and you wanted to make sure it's uh, the K reverse linked list, right? You actually use a code which is already there and started building on top of that. Uh, One tip I would give you, whenever there is a class that is already there, start using the class functions as much as possible.
Okay. So you mean to say that reverse English I did,
Yep.
could I use that function? Only
Yeah.
problem was I was using that head pointer. That was bugging me.
Yeah.
Actually, I thought it will be very useful, but when I was going to start the code, I realized that I might miss. I miss up. Uh, I think it was very
Yeah.
helpful session. I need to rehearse few questions,
Yeah.
revise.
And I would ask the viewers to start revising on things. See, recursion is very easy. Start using iteration. It makes it a little bit of a challenge. And if you go right into iteration and you say that, see, recursion is easy, iteration is hard, I'll tell you how the iteration works and how optimal these are, then that is pretty good. Like you need to leverage a lot of these tools, but yeah, that works a lot. So I think this was a really good session. Tusha, you did a really good job. And I feel that you are building up courage and you are building up the design. Like you are actually practicing a lot. So I feel there is like from the last session, I see a lot of improvement with you. So kudos for that. And I think all viewers can agree to that. Uh, anyway, the thing is, yeah, sorry. Yeah, so it was a great interview. I think we should wrap up. I think uh, for all the viewers, please subscribe and uh, do wait for the next session. It's probably going to be on Tuesday next week. Yeah. Thank you, everyone. Thank you, Tushar, and have a happy weekend.